Howdy everyone. All right, I believe I am finished with fitting the fiberglass tips, if you will, on the rudder itself. So I believe I've talked about the bottom one. This is the finished product. Of course, I don't have a cleat coat in place, but it's finished and ready to go, I believe. I think I talked about this before, I don't remember, but I added a couple of extra holes. I added one up here, and I don't know if, I think maybe one back here may be extra, or maybe it's this one. I don't remember, but there were a couple. This is one of them, this one up here. And when you drill these holes, of course, you have to pay attention to the piece that's underneath, the metal strip here. This metal strip is only so long, so don't get too over ambitious and try to drill a hole somewhere out here where there's nothing to attach it to underneath. But there it is, ready to go. You can see the cutout, and I've talked about this before. You want space all the way around this cutout, or all the way around this bracket, this horn. You want some good spacing between it and the fiberglass. These gaps, for me, it's kind of hard to tell. They're a little bit bigger than I'd like them to be, but they're fine. Pay attention to that. You have to make this cutout here on the fiberglass. You can kind of eyeball this with this one to get this. You want this edge here basically parallel with this edge here. That's about it. I mean, it's kind of simple stuff, right? We've all done this before. It's just a different material. We've done it with aluminum. Now we're doing it with fiberglass, but the methods are pretty much the same. This is the top tip. I just got this one finished. A couple of things with this one. I should have probably left it uncleat-coated, but oh crap. Oh well. Okay, so with these pieces, right, you have the tip itself, and then the flange area that goes underneath the aluminum, it's kind of stepped, right? So you have the flange piece that fits under the aluminum, then there's a step, and then the rest of this piece, okay? This front face here did not have that step. It was smooth all the way down. So what I ended up doing, this front face was thick enough that I was able to sand down just this area here. I filed down this area here. I basically just took this step on this edge and the step that's on this side, and I drew a line between them here to connect them. And then everything below that line, I basically just thinned out to create a step here. And that made this fit a lot nicer. And it made this whole piece was able to come forward a little bit, which closed up the gaps in the corners here. Really nice. And it also helped to get this back edge here in alignment. The other thing that you'll notice is where the holes stop. The pre-punched holes stop right here. Part of the reason for that is as this tip tapers down to the trailing edge, there's not a lot of material in here to work with. You wouldn't be able to get a rivet in here and a matching rivet from the other side because they would interfere with each other. Of course, you could stagger them. However, since this tapers down to a point, you actually have to remove the flange that these clecos go through on the tip itself. That fiberglass flange that's in here, you actually have to remove it back here in the corner so that this will fit. So I just cut off about 1 inch. You've got this whole thing to work with. You could remove the flange across this whole thing up to, of course you want to leave your edge distance, but you could remove this flange from the tip all the way back into here. I left it because I wanted it for strength, but I just removed like 1 inch from here to get that to fit. So there's a lead weight up here, but it's already completely encased. It's already riveted in place. There's no access to it. So I'm assuming, and I believe I've read this, but I don't recall if that's an accurate statement. I believe I had read that this particular weight on the rudder does not need to be balanced. Don't take my word for it, but it kind of makes sense because when you build the rudder, that gets encased with riveted parts, and there's no adjustment that you can do. Of course, you have to have all this put together to paint it, and you're supposed to have it painted when you do your balancing. So anywho, the weight is in, and there's no access to it. This is just a tip with nothing else needed to be done to it. This is the bottom piece, and for me, there's nothing else for me to do to it because I am not using the tail light. So I don't see any reason why I cannot rivet these on. So I'm going to go ahead, like I've talked about before, I'm going to clean everything really well. And like I talked about before, I'm going to use fuel tank sealant. And I'm going to mix up a batch of fuel tank sealant. I'm going to put it on here, of course, underneath. Go ahead and do my pop rivets and then wipe everything down. And that fuel tank sealant will create a nice little transition between these two pieces. And of course, it helps seal from any kind of rain that might seep in. That's really not that important. I mean, you know, what are you going to do with this? Rain's not going to get in here, you know. But it will create that nice little transition. You know, there's some high spots here where you have the skins doubled up. You got a skin on top of a skin. So in here, there's a little bit more of a gap than there is down here. That fuel tank sealant, again, will help with that. If you got edge distance problems with your fiberglass pieces, of course, the fuel tank sealant will help reinforce this whole connection over time. If those pop rivets do crack the fiberglass, you still got your fuel tank sealant as a backup, if you will. So it's structurally nice and sound. So that's my next step. Clean up stuff, mix up some fuel tank sealant, and I'm going to rivet these on. I'll get that knocked out, and I will talk to you guys later.